Metallic conduit passing through a bored concrete wall, or any wall for that matter, cannot be considered a sole means of support. The National Electrical Code does not explicitly state this. However, the NEC provides general requirements for supporting electrical equipment, including conduits. NEC Section 300.11 states support for conduits and conductors shall be secured to minimize the possibility of damage to the conductor's splices or insulation by bending or vibration. NEC Section 300.12 states securing and supporting conduit shall be securely fastened in place and supported in such a manner as to prevent physical damage to the conduit or conductors. Proper support methods for conduits passing through a bored concrete wall include, firstly, using conduit straps or clamps attached to the wall or ceiling; secondly, using a conduit hanger; thirdly, using a concrete-filled core hole with a conduit sleeve; and fourthly, providing additional support within the wall cavity, such as a metal stud or a lintel over the hole. Considering the code requirements for secure and stable support, relying solely on the wall penetration is insufficient. The conduit needs additional support to prevent movement, vibration, and potential damage to the conductors inside. Let's delve into the specifics of NEC Sections 300.11 and 300.12. Section 300.11 focuses on the mechanical integrity of the installation. It emphasizes that the support system must minimize the risk of damage to the conductors, splices, and insulation. This means the support should be robust enough to withstand environmental factors such as temperature changes and vibrations, without causing undue stress on the wiring. The type of support needed will vary depending on the installation environment. For example, in areas prone to vibration, such as near heavy machinery, more robust support systems are required. Section 300.12 reinforces the need for secure fastening and support. This ensures the conduit remains in place and is protected from physical damage. The support must be designed to prevent the conduit from sagging, shifting, or becoming dislodged over time. The type of support used should be appropriate for the size and weight of the conduit, as well as the specific environmental conditions. For example, in corrosive environments, corrosion-resistant materials should be used for the support system. Let's consider the proper support methods in more detail. Conduit straps or clamps provide a direct and secure means of attaching the conduit to the wall or ceiling. These straps or clamps should be spaced appropriately to provide adequate support along the length of the conduit. The spacing will depend on the size and type of conduit, as well as the support requirements outlined in the NEC. Conduit hangers are designed to suspend the conduit from overhead structures. These hangers can be attached to ceilings, beams, or other suitable supports. Conduit hangers are particularly useful when running conduit across open spaces or in areas where direct attachment to the wall is not feasible. A concrete-filled core hole with a conduit sleeve provides a robust and durable support solution. This method involves creating a hole in the concrete wall that is slightly larger than the conduit. A sleeve, typically made of PVC or metal, is then inserted into the hole to protect the conduit from direct contact with the concrete. The space between the sleeve and the conduit is filled with concrete, providing a solid and secure support. Providing additional support within the wall cavity can enhance the stability of the conduit installation. This can involve using metal studs or lintels to provide additional support points within the wall. These supports should be securely fastened to the wall structure to ensure they can withstand the weight and stress of the conduit. When selecting support methods, several factors should be considered. Firstly, the size and type of conduit; secondly, the environmental conditions; thirdly, the structural integrity of the wall or ceiling; fourthly, the applicable codes and standards; and fifthly, the accessibility for future maintenance. The size and type of conduit will determine the appropriate size and type of support. Larger and heavier conduits will require more robust support systems. The environmental conditions, such as temperature, humidity, and exposure to corrosive substances, will affect the choice of materials for the support system. In corrosive environments, corrosion-resistant material should be used. The structural integrity of the wall or ceiling will determine the load-bearing capacity of the support system. The support system must be able to withstand the weight of the conduit and any additional loads. The applicable codes and standards, such as the NEC, provide specific requirements for supporting conduits. These requirements must be followed to ensure a safe and compliant installation. Accessibility for future maintenance should be considered when selecting support methods. The support system should be designed to allow for easy access to the conduit for inspection and repair. In summary, while passing conduit through a bored hole in a wall provides a degree of physical constraint, it does not satisfy the NEC requirements for secure and independent support. The code emphasizes the need for additional support using methods like straps, hangers, sleeves, or internal wall bracing. By implementing these measures, the electrical installation remains safe, reliable, and compliant with industry standards. Remember that proper support not only meets code requirements but also extends the lifespan of the conduit system by preventing premature wear and tear. Ignoring these guidelines could lead to hazardous conditions and costly repairs in the future. Always consult the latest edition of the NEC and local regulations for the most up-to-date requirements. Consider engaging a qualified electrician to ensure the installation is performed safely and correctly, particularly in complex or critical applications. Let's talk about some common mistakes to avoid when supporting conduit. One common mistake is overspacing supports. The NEC specifies maximum support intervals for different types and sizes of conduit. Exceeding these intervals can lead to sagging and potential damage. Another mistake is using improper support materials. Using materials that are not rated for the environment or the weight of the conduit can lead to premature failure. For example, using plastic straps in a high-temperature environment can cause them to melt and fail. A third mistake is failing to properly secure supports to the wall or ceiling. Supports that are not securely fastened can come loose over time, compromising the integrity of the installation. Make sure to use appropriate fasteners and anchoring techniques. A fourth mistake is ignoring the potential for corrosion. In corrosive environments, it is essential to use corrosion-resistant materials for both the conduit and the support system. This will help to prevent premature failure and ensure the long-term reliability of the installation. A fifth mistake is neglecting to consider the impact of vibration. In areas prone to vibration, it is important to use support systems that are designed to dampen vibration and prevent damage to the conduit and conductors. This may involve using vibration-isolating hangers or flexible conduit connectors. Finally, always remember to inspect the support system regularly for signs of wear and tear. This will help to identify potential problems early on and prevent costly repairs down the road. Look for signs of corrosion, loose fasteners, and sagging conduit. If any problems are found, take corrective action immediately. In conclusion, proper conduit support is essential for ensuring the safety, reliability, and longevity of electrical installations. By following the NEC guidelines and avoiding common mistakes, electrical professionals can create installations that are both safe and compliant. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. The type of wall construction also plays a role in determining the appropriate support method. For example, supporting conduit on a concrete wall will require different techniques than supporting conduit on a drywall wall. Concrete walls offer a solid and stable surface for attaching supports. Common methods include using concrete anchors, expansion bolts, or powder-actuated fasteners. These fasteners provide a secure connection to the concrete and can withstand the weight of the conduit. Drywall walls, on the other hand, are less structurally sound and require different support techniques. One common method is to use drywall anchors or toggle bolts to attach supports to the wall studs. These anchors provide a secure connection to the studs and can distribute the weight of the conduit over a larger area. Another method is to use a backer board behind the drywall to provide additional support. The backer board is typically made of plywood or OSB and is attached to the studs. The conduit supports are then attached to the backer board, providing a more secure and stable connection. When running conduit through a wall cavity, it is important to ensure that the conduit is properly supported within the cavity. This can be accomplished by using metal studs, wood studs, or other structural members to provide support points. A conduit should be securely fastened to these supports using appropriate fasteners. It is also important to ensure that the conduit is protected from physical damage within the wall cavity. This can be accomplished by using a conduit sleeve or by providing additional protection around the conduit. The conduit sleeve should be made of a durable material, such as PVC or metal, and should be sized to fit snugly around the conduit. The additional protection can be provided by wrapping the conduit with a layer of insulation or by installing a protective cover over the conduit. When running conduit across a ceiling, it is important to ensure that the conduit is properly supported from the ceiling structure. This can be accomplished by using conduit hangers, trapeze hangers, or other suitable support devices. The hanger should be securely attached to the ceiling structure using appropriate fasteners. The spacing between the hanger should be in accordance with the NEC requirements. It is also important to ensure that the conduit is protected from physical damage when running across a ceiling. This can be accomplished by using a conduit sleeve or by providing additional protection around the conduit. The conduit sleeve should be made of a durable material such as PVC or metal and should be sized to fit snugly around the conduit. The additional protection can be provided by wrapping the conduit with a layer of insulation or by installing a protective cover over the conduit. In addition to the mechanical support of the conduit, it is also important to consider the electrical safety aspects of the installation. This includes ensuring that the conduit is properly grounded and bonded. Grounding and bonding help to prevent electrical shock hazards and ensure the safe operation of electrical equipment. The NEC provides specific requirements for grounding and bonding of electrical systems. These requirements must be followed to ensure a safe and compliant installation. The grounding conductor should be sized in accordance with the NEC requirements and should be connected to a grounding electrode system. The bonding conductor should be sized in accordance with the NEC requirements and should be connected to all metal parts of the electrical system. When installing conduit in a hazardous location, it is important to follow the specific requirements for hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. The NEC classifies hazardous locations into different classes and divisions. Each class and division has specific requirements for electrical equipment and wiring. Conduit installed in a hazardous location must be suitable for the class and division of the location. This may require the use of explosion-proof conduit fittings and seals. It is also important to ensure that the conduit is properly grounded and bonded. In conclusion, proper conduit installation is essential for ensuring the safety, reliability, and longevity of electrical systems. By following the NEC guidelines and using appropriate support methods, electrical professionals can create installations that are both safe and compliant. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns.